sir. My name is Danish Mohanadas. My metric number is B0819100149. So this is the question that I have done, which is we have to find the IB value, IC value, IE value, and the voltage VCE, which is from collector to emitter. And the second part is we have to find whether this circuit is saturated or not. For the first one, now we will look at the calculated part. So to find the IB value, which is current at base, VBB minus VBE over RB. VBE is the voltage drop that occur at base to emitter, which is 0.7 volt approximately, and the value that we will get finalized is 702.13 microampere. Next is IC. For IC, beta times IB, and the value that we will get is 70.213 milliampere. The third one that we must find is the IE. IE, we must find with IC plus IB, and the value that we will get is 70.92 milliampere. The last one in part 1 is VCE. To find the VCE, we must first use the formula VCC minus ICRC, and the value that we will get is negative 9 volt, and also it can be 9 volt. That in the diagram it is given that the VCE value is 8 volt. The value that I get is 9 volt. Next, for the part 2, we will have to determine whether this circuit is saturated or not. So it is given that the VCE saturation is 0.3 volt and the BDC value is 50. To determine it, first we have to know the IC saturation. To find the IC saturation, we must use the formula VCC minus VCE saturation, which is already given 0.3 volt over RC, which is 470 ohm. So 24 volt minus 0.3 volt over 470 ohm, we will get the value 50.43 milliampere. Now we must see whether the IB is larger enough to produce the IC saturation. So IB value VBB minus VBE over RB. VBE is 0.7 volt, so we will the end of this answer we will get 702.13 microampere. For the IC, BDC, the value which is already given 50, BDC times IB, and we will get approximately 35.12 milliampere. So as finalized, we can say that IC saturation is greater than IC, so therefore it is not saturated. Base current, the base current is not capable of producing IC greater than the IC saturation. We look at the simulation part. So what we have to determine is the IC value, IB value, and the IE value. To determine that, we must use the ammeter. So as we can see, the IC value that I get from the simulation is 50.7 milliampere, and the IB value is 665 microampere, and the IE value is 51.4 milliampere. So we can compare it to the calculated one. So for the calculated one, the IB value is 702.13 microampere, which I get in simulation is 665 microampere. As for the IC value I get in calculated is 70.213 milliampere, and the IE value is 70.92 milliampere. We can compare it to the the one that has been done in the simulation. So the IC is 50.7 milliampere, the IE is 51.4 milliampere, and the IB is 665 microampere. That's all from me as for the question 1. Thank you.
Hello, I'm Sharmaragan, son of Murali, matrix number B0819100045 from BEA S1/1, would like to present about question 2 assignment 1 bipolar junction transistor BJT. Question 2. Refer to the circuit in figure 2. Determine the collector current, base current, emitter current, collector to emitter voltage and collector to base voltage. Given beta DC equals to 125. This will be the setup of circuit in multisim to obtain all the values. To get the values, we should press the play symbol and stop it to get the values. Now all the values are appeared on the screen. Now we should do calculation theoretically using formula. First, to calculate IB, the formula is VCC minus VBE over RB plus beta plus 1 RE. So the value of VCC from the circuit is 20 and VBE is 0.7 and the value of RB is 270 kilo ohm and beta is given 125 and the value of RE is 2.2 kilo ohm. So the value of IBQ is 35.27 microampere. To calculate the value of IC, the formula is beta IB. So the value of beta is given 125 and the value of IB is obtained 35.27 microampere. The value of IC is 4.41 milliampere. While to calculate IE, the formula is IC plus IB. The value of IC is obtained and which is equals to 4.41 milliampere and value of IB which is equals to 35.27 microampere. The value of IE is 4.45 milliampere. Next, to calculate the collector of emitter voltage VCE, the formula is VCC minus IC bracket RC plus RE. The value of VCC is given which is equals to 20 volt and value of IC is 4.41 milliampere. RC will be 470 ohm and RE is 2.2k. So the value of VCE is equals to 8.23 volt. While to calculate collector of base voltage VCB, the formula is VCE minus VBE. Value of VCE is gain which is 8.23 volt while voltage of VBE is equals to 0.7. So the value of VCB is 7.53. The values obtained from this calculation and the values which is obtained from the simulation has been tabulated. There are plus minus 10% of changes for calculation and multisim because computer floating points has finite precision and can accumulate errors over the course of simulation. Thank you.
Hello, my name is Rishidharan Gnanasekharan and my matrix number is B0819100423. Okay, so today I'm going to explain you about question 3. Okay, so the first question is determine if the uh, transistor is in stiff condition or not. Okay, so in this circuit it is stiff condition because your your RB have to be 10 times greater than your uh, RB2. Okay, so in this case the circuit is in stiff condition. Okay, so next I have to find the IC and VCE. Okay, so to find the IC and VCE, I've made up the circuit. Okay, so I'll stop and run back the simulation. Okay, so once I run, I will get the value here. So for the IC, I get 4.2 milliampere, and for VCE, I get 9.237 watt. Okay, so for this multisim, I get this. Okay, so when we compare with the mathematical approach, there is difference. Okay, so now I will show you the mathematical approach. Okay, so this is in the mathematical approach, so we have to find the IC and VCE. So in normal way of calculation, we have to find IC and VCE. Okay, so the first step is we have to find the VThevenin for this side of the circuit. Okay, so VThevenin for this R1 and R2. Once you find the VThevenin, you should find the RThevenin. So VThevenin is VCC times R2 over R total, which is 3.33 watt, and RThevenin is we have to do the parallel. So we get 8.33 kilo ohm. So this is the new type of circuit. I mean the another example. Once you combine this, so your RThevenin will go here and your VThevenin will go here. Okay, so once you get this, you have to find IB. So the formula for IB is VTH over BB over RTH times beta plus 1. Okay, so for this, the beta given is 200. Okay, so once we sub in everything, we will get this value. Okay, so once you get this value, we have to we have to find IC. So the formula for IC is beta times the IB. So when I sub in the values, I get 2.513 milliampere. Okay, once I get the IC 2.513 milliampere, I calculate the VCE. I mean the voltage across collector to emitter. So the VCE is 9.948 watt. Okay, so as you can see, now we are going to compare with the multisims result. Okay, so now let's have a look on the VCE. So VCE in this shows 9.948. In the multisim it shows 9.237 watt. Okay, now okay, next we are going to compare the IC here. It shows 4.2 milliampere, and here as you can see it shows this 2.513 milliampere. Okay, so the reason for the difference is in the multisim simulation we never use the beta value, and while in the mathematical approach we have to include our beta value. So this is another factor that causes the difference. And also multisim, as we all know, it is normal to get different answer between multisim and mathematical approach. So when we plus minus the values, it is nearly less than 10% of the difference. So that's all from me. Thank you guys.